In this video, we are going to learn how to delete a node from a binary search tree. We have to consider three cases while we perform deletion in a binary search tree. Here is an example of a BST, and the first case is if the node to be deleted is a leaf node. And suppose we have to delete 300, which is a leaf node here. There are no complexities to delete a leaf node, so simply delete it. The second case is when we have to delete a node with a single child. Then we can delete that node and its child takes its position. That is, if the node to be deleted has only a right child, delete that node and its right child takes its position. For example, let us delete the node 200. It has only a right child, which is 300. So delete 200 and its child 300 takes 200's position. Similarly, if the node to be deleted has a left child, only a left child, delete the node and its left child takes that position. For example, let us delete 200 here. It has only one child, 150, which is its left child. So to delete 200, we can delete it and 150 takes its position. Like this. So that was the second case. The first case is node with no children. The second case is node with a single child. And next is the third case, which is obviously a node with two children. So in that case, we have to find the in-order successor and replace the node to be deleted with it. See an example, node 200. It has both left child and right child. So this is our third case. And what is an in-order successor? It will be the node that comes immediately after this particular node in the in-order traversal. We can easily find it because it will be the minimum value in its right subtree. And we know the minimum value of any subtree of binary search tree will be its leftmost node. We have learned that. So to delete 200, we have to delete 200 and its in-order successor takes that position. And which is the in-order successor of 200? It will be the minimum value in right subtree, which is 250 here. So delete 200 and 250 takes its position. So now let us see how to implement it in Java. So we have this function remove node to do that. We will pass the root of the tree and value to be deleted and it returns the tree after deletion. So we have public node remove node of node root int val. So let us divide this deletion process into 4 steps. First, check if the tree is empty. If not, find the node to be deleted. Once the node to be deleted is found, find the case applicable. That is, we learned 3 cases. Node with no child, single child and 2 children. Once the case is identified, take appropriate action. This is what we are going to do. So here, let us delete the node 10. So first check if the tree is empty. For that, we have if root equal to null. And if it is, return null. But here, it is not. So what is the next step? Find the node to be deleted. Here, val equal to 10. So we have to find the node with data 10. Then only we can delete it. And we know elements less than root will be to the left side and larger than root will be to the right side. And here, the logic that we are using is, we will check if this node is less than the root, then we will check in the left subtree only. So call the function remove node for left subtree only. And if node is greater than root, we will check in the right subtree only. So call function remove node for right subtree. If it is not less than or greater than root, then the node to be deleted is the root. So we can proceed with our deletion. So let us see how it works. We have val equal to 10. So check if root key is less than val and 100 is not less than val. So check if root key is greater than val and 100 is greater than 10. So the value is less than the root. So we only need to check in the left subtree. So call remove node by passing the left subtree. So how do you pass a subtree? To pass a tree, you can pass its root. A root has links to all the nodes. Similarly, to pass a subtree, you can pass the root of its subtree. We have root left equal to remove node of root left comma val. So if 10 is present in this left subtree, it will be deleted and that subtree will be returned to this function and it will be updated here. So remove node is called again by passing node 50 and value 10. So first check if the tree is empty, but it is not. So check if root key is less than val, but 50 is not less than 10. So check if root key is greater than val and 50 is greater than 10. So again 10 can be present in the left subtree only. So repeat the step called remove node by passing the left subtree and the value. So remove node is called again by passing the node 10 and the value 10. Now again check if the tree is empty, but it is not. So check if root key is less than val, but 10 is not less than 10. So next check if root key is greater than val and 10 is not greater than 10 too. So as we discussed, 10 is not less than root and 10 is not greater than root. So 10 must be the root here. So else part will work here. That is, we found the node to be deleted, which is the root of this subtree. So we performed two steps, checking if the tree is empty and if not, finding the node to be deleted. Now, what is the third step? It is identifying the deletion case. So first check if it is a node with no children, that is, if it is a leaf node. And if it is a leaf node, then its left and right will be null. So check if root left equal to null and root right equal to null. And here it is. So the third step is done, the case is identified. Now what is the final step? Take appropriate action. So we know if it is a leaf node, we can simply delete it. So return null. And please understand that this is not the root of the whole tree, but of the subtree we passed. This function is called for the third time here, and the root we are referring here is the node with value 10. So the root of this subtree is deleted, so return null to the calling function. And finally, root of the original tree will be returned to the function called remove node first. So that is how we can delete a leaf node. Now let us delete another node. Let it be the node with value 300. So val equal to 300. So as we discussed, first check if the tree is empty, but it is not. So check if root key is less than val, and we have 100 less than 300. So 300 can be present in the right subtree only. So call remove node by passing its right subtree and the value. So remove node is called again by passing node 200, which is the root of right subtree, and the value 300. Now again check if the tree is empty, but it is not. So check if root key is less than val and 200 is less than 300. So this is true. So 300 can be present in the right subtree only. So again call remove node by passing the right subtree and the value to be deleted. So call remove node by passing its right subtree and the value. So remove node is called again by passing the node 300, which is the root of right subtree, and the value 300. Now again check if the tree is empty, but it is not. 300 is not less than the root and 300 is not greater than the root. So 300 must be the root here. So we have found the node to be deleted, and the next step is to identify the deletion case. So first check if it is a leaf node, and we have if root left equal to null and root right equal to null. But it fails since root left is not equal to null. So the statement inside will be skipped. Now check if it is a only right child case. So check if root left equal to null, and it is not true here. So now check if it is only left child case. So check if root right equal to null, and it is true here. So both left and right is not equal to null, but only right equal to null. So what is this? It is a only left child case. So what should we do? We have to delete that node and its child should take that position. So return left child, which will be stored as root right in the calling function. And finally, root of the original tree will be returned to the function called remove node first. So that is how a single child node can be deleted. Now let us delete another node. Let it be 200. So as we discussed, First, we need to check if the tree is empty, but it is not. So check if root key is less than val and 100 is less than 200. So 200 can be present in the right subtree only. So call remove node by passing its right subtree and the value. So remove node is called again by passing node 200, which is the root of right subtree, and the value 200. Now again check if the tree is empty, but it is not. 200 is not less than root and 200 is not greater than root. So 200 must be the root node here. So we have found the node to be deleted. Next, we need to identify the deletion case. So first check if it is a leaf node. So we have if root left equal to null and root right equal to null, but it is not. So check if it is only right child case. So check if root left equal to null, but it fails here. So next check if it is only left child case. So check if root right equal to null, but it also fails here. So it is not a leaf node case, not single left child case, and not single right child case. So it must be both left and right child case. That is the two children case. So in this case, what should we do? We need to find the in-order successor of 200, that is the minimum value in right subtree of 200. So let us call a function getRightMin by passing its right subtree, that is node 300. So write int rightmin equal to getRightMin of root right. So what we have to do in this function is we have to traverse through the left child till we get a null. So create temp pointing to root and use a while loop while temp left not equal to null and move temp to its left child. So first temp points to 300 and now we have temp left equal to 250, which is not equal to null. So go inside and move temp to its left child. So temp equal to 250 now. Now again check if temp left not equal to null, but it is here. So control comes out of the while loop and returns temp key, which will be the in-order successor, and it will be stored in integer variable rightmin here. So copy this in-order successor to node to be deleted, which is root here. So we have root key equal to rightmin. So 250 is stored here. Now we have to delete the original node with 250. So call remove node function by passing right subtree, root right, and in-order successor value 250. Now again check if tree is empty, but it is not. So check if root key is greater than val and we have 300 greater than 250. So call remove node function by passing the left subtree and the value 250. And here first check if tree is empty, but it is not. 250 is not less than root and not even greater than root. So it must be the root here. So we have found the node to be deleted. So identify the deletion case. So first check if it is a leaf node and we have if root left equal to null and root right equal to null. And it is true here. So this is a leaf node case. So simply delete it. So return null. And finally the root will be returned. So that is how deletion can be performed in a binary search tree.